Coming to properties of tensor products, as long as tensor products are with vectors and matrices, things are different. When it comes to operators, then things would be different. Now, first let's construct ket xi. That is nothing but ket phi tensor product of course, ket phi 1 and phi 2. Okay. Now, linearity property of tensor products. Linearity. The first one, what that is suppose if I have ket xi, tensor product of ket phi 1, phi 2, then what happens is separately it's been operator, tensor product, ket xi 1. Okay. This is pre-multiplying. Suppose if I have something like post-multiplying, it's all about writing the notation, which is a bit tedious. Otherwise, I don't think you need to struggle with the concepts if you understand properly. Ket phi 1 tensor product ket xi plus ket phi 2 tensor product ket phi. There is no 2. I'm just repeating it by default like the previous one. Okay. There's one more. There's one more version of linearity. Ket phi tensor product alpha into ket xi. Alpha is a scalar. So alpha is taken out. Nothing to do with the tensor product. Ket phi tensor product of ket xi. Okay. Tensor product is linear with respect to scalars. Okay. Order is irrelevant. Order of tensor product is irrelevant. That's the second property. Order is irrelevant. That is, it is tensor product of ket phi and ket xi. There is no 2. Both are same. Of course, as mentioned in the previous video, tensor product of ket phi and ket xi is nothing but, I'll write it in shorthand notation, phi xi. Okay, this is one version. Another version is phi greater than xi, kind. Okay, yeah. Now, when operated with operators, tensor product with operators, how it operates, third one, that is, if I'm asked to find this ket xi, I know what is ket xi. Just have a look. I have defined or constructed ket xi to be the tensor product of ket phi 1 and ket phi 2. So how it acts upon, just see. A tensor product of B ket phi 1 tensor product of ket phi 2. Okay. Separately, they are operated upon. That's what it means. Okay. It is like A ket phi tensor product of B ket phi. Phi 1 ket phi 2. Okay. Or this is nothing but A tensor product of ket phi 1. The operator A operates on the first ket. Operator B operates on the second ket with tensor product. And finally, the tensor product of the both resultants would be taken. Resultants would be taken. Okay. We'll just see one example. Prior to this, we have seen tensor product of vectors and matrices. We'll see one example with tensor product of operators. given a question, if ket xi is tensor product of ket 0 plus ket 1 under root 2, find I tensor product of y ket xi. Okay. Yeah, I is nothing but the identity operator, guys, like our identity matrices in matrix theory. Okay, I'll just write what I is. All of you know what I is. Y also I have defined in the previous video, the Pauli Y gate. Y is nothing but the 0 I minus I 0. Okay, the Pauli Y gate. So tensor product. Xi is being given to me as tensor product of two things. Let me write what they are so that I can apply the property properly. Okay. Given what is ket xi? Tensor product of ket 0 and ket 0 plus tensor product of ket 1 into ket 1 by root 2. Okay. Yeah. So how do I do it? According to the properties of this thing. I tensor product of y okay and ket xi. Okay, so this value, how I'll be calculating is I tensor product of y 1 by root 2, of course, is a constant. Ket 0 tensor product ket 0 plus, of course, I can take the value and then finally finish off. But anyways, how operators operate upon tensor product is what I'm trying to stress upon here. So let me do it. So what happens is, whenever I am with tensor product, and just use a different color. The first one goes with the first one of operators. Why? Because I and Y are operators. The Pauli operators. This is the identity operator. As discussed earlier, Y is the Pauli Y operator. Okay. So first one goes with the first, second one goes with the second. So 1 by root 2 is a constant like alpha. So I take it out. I get 0. Of course, tensor product sign also can be there, of course, or otherwise this is also fine. Okay. And then tensor product y ket 0. Of course, tensor product of ket 0 and ket 0 I can evaluate, then go ahead. But then I just want to show this operator part. That's the reason I'm writing it like this. Okay. Similarly, with the second one as well. The first one goes with the first. And the second one goes with the second. Okay. So there's a plus sign. I, tensor product of 1. Tensor product of y, tensor product of 1. Okay. Yeah. So what happens is 1 by root 2. I have all these results actually. I'll be checking. Okay. What I, when operated upon ket 0, would give me what? 1 0 0 0 1 0. It's an identity operator. So 1 0 is get 0. So I'll be having get 0 only. Okay. Yeah. Coming to y get 0. 0 I minus I 0 1 0. Okay. Let's see what this gives me. 0 0. First one is 0. Second one is I plus 0. So it is nothing but I into ket1. Okay. Next. How does I operate upon ket1? I operating upon ket1. Okay. Of course, identity operator. So ket1 only. Why? How does it operate on ket1? I'll show you. I'll do and show so that things are easy. 0 1. Okay. So 0 and then minus I. First element is 0 and 0. So this is nothing but minus I of ket0. Okay. So what do I have is, of course, I can write the vector or I can write this notation. First, I'll go with the notation, then come to the vectors because tensor product resultant I have to write now. Ket0, tensor product of I ket1. Okay. Plus ket1, tensor product of minus I ket0. Okay. Yeah. Of course, this is the final notation that I can leave with. Or I can just go with what the values are like. Okay. 1 by root 2. Ket0 is 1 0. Tensor product of 0 I. Okay. Plus ket1 is 0 1. Tensor product of minus I 0. In the previous videos, anyways, we checked how to find the tensor product. So 1 by root 2. 1 into 0I, 0 into 0I. Okay. There will be one vector here. Another vector would be 0 into minus I 0, 1 into minus I 0. Okay. So 1 by root 2, 0 I, 0, 0 is the first one. Second one, 0 into anything is 0, 0, 0, minus I, 0. I add both. So finally what I will get would be 0 plus 0 is 0. I plus 0 is I. Minus I and 0. Okay. This is the resultant. Of course, I can check, rewrite it as something else as well. Okay. I'm just asked to find. So I will just leave it here. This is how I will find. I will operate operators. Here, the motive finally is when I have two matrices. Okay, I tensor product of two matrices and tensor product of two kets. How they'll be operated? Of course, I and y are matrices as well as operators. Okay, when I have two operators, how they'll be operated upon two kets is first one is for the first, second one is for the second. That's the resultant that I ought to know here. Okay. I will end this video here.